Okay, advent of code, day 3 in 10 seconds. Here we go. Oh boy. Okay. Any number adjacent to a symbol. Symbol is okay. Anything that's not a digit and not a dot. Okay. And then if it's not a dot and it's not a digit, then we count it. If s dx in range when s and j plus dy in range when oops paren s plus dx. Okay, then we count it. Oh, that is not an answer. That is the answer. Nope. What did I do wrong? Oh, you have to read off the entire number. Okay. Shoot, that's trickier. Okay. Well, we parse it left to right anyway, so this is fine. Keep. Okay, so if we're a digit, if this happens, then keep gets set. If we're a digit and this doesn't happen, nothing. If we're not a digit, then thing gets reset, keep gets reset. If we are a digit, regardless, thing plus equals v. Then at the end of, at this point, if keep and one thing, okay, greater than 0. Then we gotta do the same thing at the end. No! This is so sad. Even diagonally. Okay, sample input time. And what we're gonna do is whenever we do this, keep, no, print. Oh, not keep. Oh, silly. Okay, so I think that actually looks fine. Let's get rid of the sample input. I don't want to print this anymore. It's a big number. I'm probably locked out right now. 16, 14. I could have checked this on the sample input, but I think it's more important right now to be spamming. Not spamming. Don't want Eric to get mad at me for saying that. Submitting a few times. Okay, rank 12. And then gear is any adjacent to exactly 2 part numbers. Okay, now what we're gonna do is Okay, so I think here's what we're gonna do. We're gonna reinvent pointers, and when we see an is digit, we are going to also do the following. So in this case, will be thing.a. So this should not change our answer. It has no len. Thing.a. Ooh, that was a bug, this thing at the end. I'm glad that I didn't get caught out on that. If I had a number at the very end, it would have failed. Okay. So now we have this sort of fake pointer, and what we're going to do is, once we have visited the cell, so if it was a digit, so we've already got what we need from this cell, we're just going to reassign Sij to be the pointer to this thing. Again, should not change the, why do we need to go back through this? Sij is thing. Oh, because we need this. Okay, let's create S2. Sorry, getting rid of the pointer thing. That was silly. Now I gotta write so much code to undo that change. That was killer. Okay. S2 is just going to be. Oh no, I do want. I do want the pointer thing. Okay. Okay. S2. Okay, so this is just none, and instead we're going to set it in S2. So these are going to be pointers, the numbers. We need this so that when we complete the number, we have a whole number. I think this should not change our answer. Not change your answer, good. Okay, now what we're going to do is if we're a gear, now we need to find adjacent numbers for the adjacency, and if so what we're going to do now is S2, let's do I plus dx range s j plus dy range s plus dx. Then if S2 I plus dx j plus dy is not none, it's exactly 2, then what we want is the 2, okay, gear ratio, sum of all the gear ratios, okay. Then what we're going to do okay, I just want to make sure we got some. It's a big number. It does not look right. I'll try it anyways. I'll have enough time to debug. Oh, it was the right answer, 24. Okay. Oh, 12 and 24. Whew. That is nice to have a day where I got leaderboard and in a decent position, given that yesterday I missed because I overslept. Oh man, I felt quite a bit for part 2. I wonder why. Maybe I'll go back through the video at some point and sort of look at how much time I wasted on different parts. I definitely did waste time undoing this change, like the .a change, but that wasn't that much time. I had to spend some time rewriting the loop and this iteration logic. Let me see what these times are. Yeah, I don't know. I felt like I could not have gained a whole lot, but I'm still a little surprised that I fell going into part 2. I'm trying to think if there's a different approach for part 1 that would have made that much faster. Yeah, nothing really comes to mind. But yeah, I guess real quick, I'll just talk about sort of what my actual approach was for part 2. So I think there was a comment on a previous video about asking if I could sort of explain things from basics. I think in these main videos, I will continue to not do that for the most part. I will sort of assume a base level of familiarity with programming. And I'll explain the parts of my solutions that I find interesting personally. And I might make separate videos some other time that sort of go into more basic details. But yeah, I think just like in the same video after midnight, it's a lot to sort of explain things from zero. And it gives me more time to prepare if I want to make a separate video for that. Anyways, what I found interesting about today. So the first part I think was straightforward-ish. So I generated I like this approach where I have this adjacency list, or I shouldn't call it adjacency list, but like it's a list of tuples representing like the adjacencies, and then you can use this to a good measure. It's a little annoying to have to like do the bounds checks every time. I have a thing that I like where I do like in range, and this is efficient because range doesn't like if you do in range, it doesn't actually iterate through range. The range class has special contains functions implemented. So this is actually very efficient. This is like O1. So I like doing this, but it definitely takes a little while to write. I think it's better to write than many alternatives, but still takes some time. But yeah, I think that the first part was really just like, oh, yeah, okay, so bits that were interesting. At first, I didn't realize that these numbers are multi-digit numbers. I sort of thought like go digit by digit, and I got like a wrong answer for that reason. And then I realized they're not. And one nice thing that keeps this simple is that, you know, you read numbers left to right and on the same line. So you can sort of just keep track of what you currently read, as well as keep track of a flag to whether you've seen an adjacency of a symbol. And as soon as you want to like reset the thing, like as soon as you go off of a digit, you reset it. And at that point you check to see if your flag was set. And if it was, then it was adjacent, and then you add it. Yeah, so maybe there's like a bit of cleverness there, but not too much for the most part. I think if there was anything clever there, it was realizing quickly that you read this left to right. And so you could sort of do it like this. But the approach itself is not that complicated. For part 2 now, we care about these asterisks and about like if they're adjacent to exactly 2 numbers, then you want to multiply those 2 numbers and add that to some total. Now, this is... So the way that I thought to do this was so if you just look adjacent to the asterisk, it can be like kind of annoying because, I don't know, it's possible that you're looking at like the end of a number, so you might need to go back previously to like reconstruct the whole number. And that just seems tricky and error prone, and I didn't really want to write that. There's also like weird cases, I guess it's not too bad, but like this asterisk, for instance, it's adjacent to exactly 3 digits, even though it's 2 numbers. And this can be like a little annoying. You need to like convert to numbers first and then convert to the number of numbers and then figure out if it's 2. And I sort of felt like there could be a few edge cases here. So what I ended up doing instead was whenever I start parsing a number, basically I want to put a pointer in each of these cells to some value that I end up populating with the total number. So when I see the 4, I know that this is going to be a number. I don't yet know what the number is going to be, but I store some pointer. That's what this D thing is. My naming here is not the greatest, but so I store this D value in this sort of mirror grid that's the same exact shape and filled with nuns. So at the location of the 4, I store a pointer to the D. The location of this, and then I see the 6, and I append it to my my thing that's stored in the pointer. So now I have 4, 6 as a string. And the pointer, what's important is that the pointer at the 4 points to now the string 4, 6. And then I see the 7, and now all 3 of these cells have pointers that point to the string 4, 6, 7. And this is useful because later on, when I have an asterisk and I see the 7, and I want to go back and figure out what the full number is, I just look at the pointer, and the pointer is going to have a completed number. And this works regardless of which side we sort of see the number on. So that was the idea behind this D thing. I use the class for this because like real pointers don't exist in Python, so you just sort of use a dummy class because classes are references. And then in part 2, I think I wouldn't say straightforward, but like using that, it's not too hard to just like use this information. One more neat bit is that if you are adjacent to like multiple digits, like the 5 and the 9, these both point to the same pointer. So that's why I do this check. And the default equality on the class is just like instance equality in Python. And of course, these are the exact same class, the exact same pointer. So this instance equality will realize that these are duplicates and we only add one of them to the list. I don't know. I felt like my part 2 there was much cleaner than my part 1. So I'm still a little surprised that I fell. I guess I'll look at the mega thread after and sort of see if there's any other solutions that lend themselves more easily to part 2. But yeah, that's it for day 3. I think by now the leaderboard should be filled up. So let's see where I landed on global. I'm up to 9 on global now. Still 2 spots below Antonio, but we're working our way up there. How did Antonio do today? Let's take a look. Oh, he just barely made it in on the first part. 100. Okay. Whew. Yeah, well, it's nice to be moving up in rank on the global leaderboard. Today was definitely a good day. Well, cool. That's all I have for today. See you tomorrow.